In this video, we're going to begin a new series talking about designing a Fender flare for an MR2 using 3D scan data. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to kick off a new mini series where we're talking about designing a car part based off of scan data. Now, we have a subscriber that's been gracious enough to send me some scan data of his MR2, and we're going to use that as the basis to learn how we can both prepare the mesh and a couple different ways that we can design car parts directly off of that scan data. Now, the scan data we have is high quality, but this would also work if you were designing based off of a part you created, if you 3D modeled a car that's relatively close, or if you have been using some, photogrammetry and created some scan data off of that. The methods will still apply, but what we're going to be looking at is an actual scan of the side of this MR2. Now, here in the US, this was the last generation of the MR2 that we got, and it has a pretty unique style. So I think once we get started, we can kind of play around with the shapes a little bit. There are a few wide body kits on the market for this, and we're going to take a look at some of those images. And these are just ones that I found online. So first off, I'm going to go ahead and just open some images. And this is the body style that we're working with, and this is a body kit that is available. You can see that it goes more of the sort of the boxy, the very first MR2, the more boxy sort of flared look. While the front of this car, the shape of this car was sort of a departure from the previous generation MR2. They went with a more boxy look, a very, very Porsche-esque. And there was actually what I believe was a factory wide body that was available for this car. It was pretty rare. And I believe that this is it. And you can see that what they did was they carried the intake scoops, because this is obviously mid or rear engine. The engine's back here. This is they carried that lip of this intake scoop, they pushed it wider and they carried it into the door. And if we take a look at like a stock one, this one has a wing on it, but the bumper and the fender and everything is pretty stock. So you can see here that this body line is fairly straight going back, whereas the one that has the fender flare, you can see that the door has actually been worked. The scoop sort of wraps to the door handle a little bit differently. And the taillights, you can kind of see the body line ends at the taillights, and then you've got a little bit of a factory flare in the fender. And you can see in this one that the taillights are actually quite a bit further inset from the body. So what they've done is they've gone from this position here, and they've actually gone a bit wider. Now, I don't really like the look of this. There is a ton of gap between the wheels and the fenders, and I think if you're going to do something like this, that just doesn't look very good. So, just for inspiration, they did sort of an over fender on the front. This is very like rally-esque for fender flares. And, there are a couple other kits that have been out there. And this is another version of that same kit, that same silver one. You can see here, this one has an extra little intake scoop on it, and they've extended the fuel door out. But you can get a better idea of what the back of this looks like. So the stock body ends at the taillight, and this is how far they've pushed it out, which is pretty far, in my opinion. There is one more that I have seen and I found, and that's this one here. I have absolutely no idea who makes this kit. It makes the front end look more like a Porsche Boxster or Carrera, very smooth early 2000s looking Porsche. And you can kind of see that they did a very sort of smooth fender flare. They kept the fender in the sort of original position and they blended it out very smooth. This is more reminiscent of like late 60s, early 70s GT cars, like the Pantera GT car, where they have the fender flares, and a lot of people cut those things up and mold them in. That's very reminiscent of that. You can see they kept the original door, they kept the original intake here, and they sort of just bulged it out to fit the wheels. Now, these still look like fairly small wheels, but they are really tucked. These are probably 16s, maybe a little bit bigger, but these cars are fairly small. So, they look pretty small. And now I want to look at a couple pictures of the previous generation MR2. Now, as far as MR2s, I've never owned one, but this is my favorite body style. And I wanted to look at this because this is more of The Rocket Bunny kit. Now, here in the U.S., they're branded as Rocket Bunny. I know in Japan and other places, I don't think they use Rocket Bunny as the name, but here in the U.S., we call these Rocket Bunny kits. And I really like the style of these fenders. It's kind of a cool take on, leaving the body original and then flaring out, and you can kind of see the wheels from the back. This one obviously has this sort of expansion piece here, but you can see that this is a more stock body version. This one has some pop rivets here, so you can kind of see that this flare, even though there's a lip here, this flare is actually a true over fender, whereas this one's just sort of a stick-on flare. I say stick-on, it's bolted on, but it's stock body and then it's bolted on here, whereas this one has more of the fender. And we can see that from a side view as well. I'll go ahead and show a side view of this thing. This entire piece here is sort of an over fender, and the same thing on the front. But again, the cool thing is here, it ends here, which gives you a very unique look, allows you to kind of see the tire, and it's the style. It's a style preference, obviously. All right, so now that we've taken a look at all of those pictures, which took 5 or 6 minutes, let's talk about the first step in this process if you're using scan data, and that is preparing your scan data. Now, most of the time when you bring in a scan, Fusion 360 is not going to work directly with raw point cloud data. Now, that's something that traditionally, if you're using a specific scanner, you will have some sort of software. You can use MeshLab, which is free, or there's Geomagic. There's a bunch of other ones on the market that you can use. So by the time we get the data to Fusion, we're talking about a mesh file, an STL, an OBJ, something like that. So what we want to do is we are going to go into the mesh workspace, or the contextual tab for mesh, and we now have access to all of our mesh tools. Keep in mind that if you do not have capture design history on, if you go to the bottom right-hand gear and you turn that off, then the mesh tools and the form tools are going to be here by default. And we've sort of looked at the differences of using this methodology when we're trying to design fender flares and sort of create these form bodies and so on. But in this example, we are going to have capture design history turned on. And the first step in our process is to insert a mesh. Now, I'm going to be using the rear fender mesh that the subscriber sent me. I'm not going to use his name just in case he doesn't want to be named. But again, sent me the scan data, really high quality. We can see the gap for the door. We can see this position here. Now, if you've not really done any body work on cars or spent a lot of time working on cars, when we see seams like this going into what's called the sill or the kick plate area, this is generally what happens when manufacturers weld large panels together. Now, sometimes a portion of that will be plastic. You find this a lot of times on the roof. Manufacturers have gotten really into including like a strip that seals the weld gaps and things like that. In the old days, what they would actually do is use lead, call it tinning, and they would actually sort of fill in the areas where those are. So if you have like an old car from the 60s, I was restoring an old Camaro, and the A-pillars actually had lead where the A-pillar got welded to the roof. So if you're trying to restore something or work on something back that old, then it gets pretty tricky because you have to get rid of that stuff, either heat it up or grind it out, and it's nasty to work with. But when we have this car, we've got this sort of natural seam or body line. And the reason that's important is because as we're designing a flare, we can use that as sort of a natural takeoff point. So when you look at factory wide body cars, especially ones from the 80s, you look at the Audis, you look at anything that had sort of a boxy flare to it, a lot of times you'll see that they start and end at gaps, like door seams, right? So when you look at even, the remake of the Camaro in 2010, the 5th gen and 6th gen Camaros, the rear fenders start to flare out at the door. And it's really good because there's a gap there and it visually breaks up the lines of the car. So if you try to just change the direction of the body at some other point, then it becomes fairly obvious that you just stuck something on. Now, for over fenders and flares, and like, that's not really a big deal in some of the newer styles, like the drift sort of scene, or the drift car styles where they just pop rivet on over fenders, because that stuff gets damaged and you have to be able to remove it and pop it on. So you don't spend a lot of time blending things in. If you're building more of a show car, then a lot of times you want to take the time to blend things in. And again, if we go back and we look at the pictures, this car here, everything is very smooth. Everything is blended in. They did obviously a lot of body work. And even here, that seam that I was mentioning, so the door comes down, the seam that is on the factory car, that is gone. So they've blended everything in and they've taken the time to do that. Whereas when we look at the factory car, this one has a side skirt on it, so it's covering up that seam that's underneath the door here. But again, the factory cars will have that seam there. And these are just things that we need to consider when we're thinking about our design process. So again, let's get back to the mesh. I'm kind of getting off on tangents here, but I do think it's important to sort of understand visually when we're looking at stuff like this, what we're planning on doing. So I'm not going to modify the direction or move to ground or use any of these other insert mesh options. I'm going to say okay. And now at this point, if we expand the bodies, we can see that we've got mesh body. We're going to get a warning because it's open, and Fusion 360 really likes closed meshes. We're not going to try to close this up because it's just an outside scan of the fender. All right, so you can see everything here is just sort of open. There's no point in trying to close this off. But what we do want to do is we want to take this wheel and we want to detach it from the rest of the mesh body. And the main reason that we want to do that is because factory cars have a lot of wheel gap between the tire and the fender, and also they're set in from the fender. So if you're designing a wide body, obviously your wheel is not in the stock location because it just looks silly. So what we need to do is we need to break this wheel out of this mesh. We need to move it to the position where we want to design. So I am going to do this by going into what's called Direct Edit. So with this mesh body, we're going to select Direct Edit, select our mesh body, and say OK. It's going to open up our mesh selection palette. And if you've been using the mesh workspace or the mesh tools in Fusion 360 for a while, this is the old mesh tool section. So back in the day, you would have to insert a mesh body or you would have to convert something to a mesh body, and then the mesh tools would become available. Since the addition of Paramesh sometime last year, probably about 6 months ago, those tools are now different. So to get here, we go into direct editing. Everything else is going to capture something in the timeline. So if we remesh this with a finer or more coarse mesh, then we'll capture that in the timeline, assuming we're not in direct editing. So in direct editing, we can do a few things. One is we have this mesh selection palette that pops up automatically, and I can use this brush, and I'm holding down the left mouse button, and I'm just painting the wheel. Keep in mind that I'm being careful not to sort of go over here. And sometimes you'll see like part of the caliper bracket is missing. I can just left click on that when the cursor highlights the entire body. So if you're missing something, like if you're missing part of the tire, for example, then you can rotate this around and you can sort of work on grabbing everything. And it is important that we do grab everything, noting that the mesh itself is going to look different from the back. So it has like a little bit of a different gray color. It's a little bit lighter gray, but we want to make sure that we do grab everything that we can. It's not exactly important that we do. We need to get the tire, and that's really the main thing that we want, but it makes sense for us to grab all the rest of that stuff. Now that we have it highlighted, the next thing that we want to do is go to Modify and use Separate. Now, Separate will allow us to use the selected faces. This Keep Tool Body or Keep Body section will preserve or make a copy of the original. So we'll have the original fender and the original wheel still combined as one, and then it'll break these two pieces up as their own. So if you have plans to continue to use the original, make sure that you have Keep Body checked. If you don't, then you can deselect it. Also note that the type, we can use things called face groups. So if you have a design that is more parametric and you use these face groups to generate big areas. So what Fusion 360 will do and what most mesh editing programs will do is they'll try to find harder creases, things that might be fillets, and it'll try to separate the mesh based on those groups. It's not going to work in this case because we really don't want to sit here and try to process all the rest of this stuff because it's very easy for us to select this because we don't have anything else attached to it. So we're going to use selected faces and say OK. Now if we expand the bodies folder, we have the original, and then we have the wheel and the fender. So now what we can do is we can take that wheel, we can use Move Copy, and I'm going to first move it up 30 millimeters. So this is essentially lowering the car. We could move the actual fender down, but we already have the wheel selected. We might as well just move it up. So now we've moved it up 30 millimeters, looking at lowering the car 30 millimeters, and then we need to move it out a specific distance. So if we go 25, 30 millimeters, that is pushing the wheel out about an inch. So if you took the stock size rim and you just added an inch, but kept kept the exact same back spacing. So if the mounting flange for the rim was still in the same place relative to the back of the rim, and you simply pushed it out an inch, this is what you would get. 25 millimeters is an inch, or close to an inch, I should say, but 30 millimeters again is a little bit more. To really just explore this, I'm going to make it a bit more drastic. I'm going to take it all the way out 50 millimeters. So that's assuming that you're adding 2 inches to the stock rim. Now, there are a couple of reasons why you would not want to do this. Having a deeper dish rim ends up being, on the rear, it's fine, it's okay, but it ends up being a bit worse for a steering axis. So if this was the front, we would want to be very careful not to just add a bunch of tire and rim outside of the mounting point. It messes with things like the scrub radius, and it's going to have some negative effects on how the car handles. So if you're doing this for handling, then be sure that you have a good understanding of the dynamics of your suspension. For this exercise, making a wide body, I don't think it's really going to matter, and this gives us a little bit more tire meat sticking outside of the stock fender. So now that we have it in its right position, I can say okay. And now I've got my tire, which I'm going to rename. I'm just going to call this one rim, and I'm going to call mesh body 3. I'm going to rename this body. So that way it's easy for me to remember, and I still have the original. You can see the stock position of the wheel is there. We've moved it up and we've moved it out. So again, it's a good reference just to keep in the file in case you need it. So at this point, we really don't have to do anything else to the mesh. If the mesh is extremely fine, if it has a lot of triangles and you want to reduce that, you could obviously do that. We're done in the direct editing part, so I'm going to finish direct editing. Then we still have our mesh tools, which we can do like reduce or remesh. So for example, I could remesh the wheel. If I wanted to, I can turn on a preview and we can sort of reduce it because we really don't need as much resolution for that. We could reduce that mesh. We could try to preserve the boundaries if we wanted to make sure the tire was in the exact location. And then if we say okay, again, because we're in paramesh, parametric capture, we have that captured as a feature in the timeline. So we can roll back to it. Now you can see we've gotten the tire, the actual grooves and the tread pattern on it, but the remesh ended up smoothing most of that stuff out. And we could also go through and delete some of the straggling data here, which just happens when things are in the shadow. Scanners are very particular about how they capture data. So just note that we can capture that stuff as long as we're not in direct editing. When we're in direct editing, it's going to be a destructive, consuming process, which means you make a change to the mesh and that change is there. So make sure that you at least have a copy of the original if you want to go back to it. Another thing that we can do if we want is we could remove some additional material. So for example, if you were planning on cutting out the original fender. So a lot of times when you're lowering a car, you can just roll the lip of the fender if you need extra room and you're just putting a little bit wider tire. If you are actually getting into a situation where you are pushing the wheel out and lowering it, a lot of times you're going to end up having to cut some of that fender away. Now, with the MR2 and with a lot of more modern vehicles, portions of that are actually plastic and part of the bumper, so that's a little bit easier to cut. The metal is a little bit trickier. You need to make sure that you prepare it if it's steel so it doesn't rust or get water in between, because a lot of times inner and outer pieces are welded together and then they're folded and rolled under. So you have to be real careful when you cut that. But the point of this is we could use that direct editing, we could use the selection painter, and we could remove portions of that. And again, we could maintain the original if we want to keep that in there, and we could modify a portion of the body here that we maybe want to consider. I'm going to leave everything in here. I'm not going to worry about cutting it digitally, but just note you can do that with direct editing. You can change your selection tool to paint selection. You can select the body that you want to edit. And then you can change like the brush size, you can select certain areas, And again, we're working directly on just the body here. And then we could use tools to just simply delete portions of the mesh if we wanted to get rid of it or whatever we want to do. But again, this is destructive. So in order to get it back, I need to use undo. So I'm going to finish direct editing. Again, I'm not going to be doing that, but sometimes that is important. So make sure that you understand you have to be in direct editing mode to be able to do that. So at this stage of the game, we could be ready to go in and begin creating some form bodies, but since we're 20 minutes in and it's a lot of talking, I think this is a great place to stop and at least make sure that we understand how to prepare the mesh before we get into creating our fender flare. So at this stage, if you have any questions, please let me know. As always, thanks for watching, and we'll see you in the next one.